Hello, everyone. My name is Muhammad Nasruddin, and today I will be starting the first session, which is Introduction to Power System Resilience. First, I would like to introduce the proposed series. We should highlight that reliability keeps the system running under normal conditions, while resilience ensures it continues to operate under stress. For decades, many years, power systems were designed to prevent failure through redundancy, structured planning, and predictable demand. But today, the system is evolving, as you will see through the series of short videos. We are seeing rapid growth in electrification and AI-driven demand, high density load such as data centers, increasing exposure to geopolitical and climate related disruptions. This means the challenge is no longer just technical, it is systematic and continuous. In this series, we will explore how power systems are shifting from static infrastructure to adaptive intelligence system and what it takes to design for uncertainty. At the end of this series, we are planning to host a few hours, like maybe 3 or 4 hours workshop or a training session. So please, if you are interested in attending, send me a direct mail. Why this is now matter? As we explained, or as we mentioned in the introduction, we have a rapid demand growth. It's expected that we have an increase 75% of demand by 2050. EV, electric vehicle, could add 10 to 15% load in urban grid. Rising data center. The data center consume 400 to 500 terawatt hour per year globally, projected to grow or to reach 1,000 terawatt hour by 2030. Large AI center required 100 to 500 megawatt per site, even more. Due to the increased geopolitical risk and fuel risk, we have, as we saw in Hormuz Strait, we have a 20% of global oil passed through this strait. Any disruption to this path caused 20 to 40%. In latest news, we heard about 50%, 55%, 60% increase. So this driven the energy inflation, which is directly impact on all sector, including food, industry, transportation, etc. The weather forecast, the weather changes. We have heat waves, we have storms, we have a flood, we have wildfire, etc. So the data shows that 70 to 80% of major grid disruption is due to weather. Heat waves increase peak demand by 10 to 20%. And you can check the demand between, let's say, Australia and UAE and the GCC due to heat wave, due to air conditioning load. At the end, we have energy transition pressure. Why? Because of the fast and sharply growing renewable energy installations worldwide. We have solar and wind are growing at a very high rate. We have a grid investment needs about $600 billion per year globally by 2030. These numbers force all researchers, utility operators to ask the question, why this matter now? And you will see very soon throughout the theories a clear relationship between all this data and resilience. So from this, we can conclude resilience is no longer optional. It's a system requirement because you will have a catastrophic impact if you lose, for example, a major data center. Or as we can see now, because of Strait of Hormuz, we have a major issue when it comes to numerous sectors, including food and energy. What's a power system? Before we go into all this, remember all the resilience that we're talking about, we're going to relate it to a power system. What's a power system? If you go ahead and you look at the power system, we have the electricity. Globally, we generate, this is the database on 2023, around 27,000 terawatt hour. 61% is fossil fuel. Remember, this data could change up and down. Just giving you an indications, the amount of power. You have in a transmission line, we have over 90 million kilometer in transmission line worldwide. The transmission line vary between 132 kilovolt to 765 kilovolt. This data could change. If you go do more investigation, deep investigation, it could increase. But I'm just giving you an overall pictures. In a distribution line, we have over 300 million kilometer in distribution line. The distribution line vary between 11 kilovolt to 33 kilovolt. Look, in many countries, we have 66 kilovolt. We have 110 kilovolt. So it's not under distribution, under transmission. But like I said, this is just a overall pictures. Now, look at this one. We have 8 billion people depends on reliable electricity. 70% of electricity demand from industry, building, and services. Now, if you go back and look at what's drive all this fuel, renewable energy is still maybe 30%. But at the end, renewable energy cannot stand on its own. Now we will see a transition toward energy storage and some sort of backup for renewable energy. But as we currently stand, the power system required the grid, a solid grid, to have a solid and efficient renewable energy operation. The important question, the important question, what changed? So we go from a standard power system. What does change now? What does change? I have high penetrations of renewable energy. This high penetration of renewable energy, we have 30% in 2023, up from 19% in 2010. According to some data, it's increased 10% annual growth. Renewable energy can vary up to 100% hour to hour. So suddenly you have a 100% or 90% output of your photovoltaic, suddenly you will lose it. Then you have a distributed energy. You have 1,000 gigawatt by 2023. Behind the meter storage, we're going above 50 gigawatt. Between 2023 to 2026, there's a sharp increase that this could be maybe 100 gigawatt now. But I'm showing you the figures. EV, industry, the annual increase is 4%. Electrifications, we need to add 50% by 2050. Now, what the most important element is data center. The data center goes to 400, as you mentioned, to 500 terawatt hour annually. We're going to reach 1,000 terawatt hour by 2030. And AI workload is 2 to 3 times faster growth in computer demand. So electricity demand from data center, you're expecting 10 to 15% increase. To end this small video, what's reliability versus resilience? Reliability is basically prevent outages, steady state design, redundancy focus, n-1, n+1 to n to n+1. Resilient, prepare, absorb, adapt, recover. Handle extreme and unknown events. So under reliability system, n-1 event, for example, it will only prevent a spore distortion. It can manage small distortion, while resilient, you can manage this entire distortion, this entire event. You can see the big difference. The big difference between these two will have a major impact on the way forward. On the way forward. Now I have an extra couple of slides. I will try to go through them a little bit fast, and then in the next video, we will cover them in details. I just want to highlight that even 2n and 2n plus 1 for data center is still considered under reliability. It's not under resilience, because some people, they say, look, 2n and 2n plus 1 goes under resilient. No, still under the reliability sector. Now, the core resilient function is, as we discussed, anticipation, absorb, adapt, recover. Now, what I want to show this slide before I end it and the sessions is 150 plus billion dollars are affected globally by power outages. 1.6 billion people are affected by power outages. Now, this is very important, 3 to 5 time ROI from investing into resilience. This is a very, very critical. You can see the massive return on investment, massive impact if you invest into resilience. Now, 70% of organizations plan to increase investment in resilience by 2026, according to some resources. We will continue this series in our next sessions. I hope you enjoyed it. Thank you for listening and looking forward to seeing you next time.